Functions. Composition of functions. The composition of a function g with a function f is h of x equals g of f of x. The domain of h is the set of all x values such that x is in the domain of f and f of x is in the domain of g. Example 1. Let f of x equals 2x minus 7 and g of x equal x squared plus 4. Find the following. F of g of x. So we're going to start from the inside, which is g of x, and we're going to plug it into f. So we're going to plug this in for the x here. So 2 times x squared plus 4 minus 7. So all of this goes in where this x is. Okay, so we distribute. We get 2x squared plus 8 minus 7. Combine like terms. 2x squared plus 1. So that is f of g of x. Now for g of f of x, we plug f of x, so all of this, in for the x here. So 2x minus 7 squared plus 4. Now we have to FOIL. So this is 2x minus 7 times 2x minus 7. 2x times 2x is 4x squared. 2x times negative 7 is negative 14x. Negative 7 times 2x is negative 14x. Negative 7 times negative 7 is positive 49. So now we combine like terms. So we get 4x squared minus 28x plus 49. And then we can't forget about this plus 4 here. And then we combine like terms again. So we get 4x squared minus 28x plus 53. That's our answer for that one. Now, we're going to do f of g of 3. So, we are going to take 3 and plug it in for x in g. So, 3 squared plus 4 is 9 plus 4, which is 13. Now we're going to take that and plug it into f. So 2 times 13 minus 7 is 26 minus 7, which is 19. So we start from the inside and work our way out. Or, because we've already found f of g of x, we could just plug 3 in for x up here. So 2 times 3 squared plus 1 is 2 times 9 plus 1. 2 times 9 is 18. So then we get 19. So either of these methods work. But if you're not asked to find f of g of x and you don't already have this, then it's a little bit faster, I think, to plug into g and then take that number and plug it into f. So I'm going to do that both ways again for g of f of 3. So we're going to start from the inside and plug 3 into f. So 2 times 3 minus 7, 6 minus 7, which is negative 1. Then we take that and plug it into g. So negative 1 squared plus 4 is 1 plus 4, which is 5. Or we have g of f of x here, so we can plug in 3. So we get 4 times 9 minus 28 times 3 is 84. plus 53. 4 times 9 is 36. Minus 84 plus 53 equals 5. So either method will work again. Okay, now we are going to find the domain of f, then g, then f of g of x, and then g of f of x. So the domain of f, if we look at f, which is 2x minus 7, we could plug a fraction in there, we could plug a negative in there, we can plug 0 in there. So for f, it's all real numbers, which in math shorthand is an R like this with 2 vertical lines, kind of like the paragraph symbol, but an R instead of a P. Now for g, we have x squared plus 4 as our function. We can put a fraction in there, we can put 0 in there, we can put a negative number in there. It doesn't matter, we can square anything and then add 4 to it. So again, it is all real numbers, or all real numbers, the symbol. Okay, now f of g of x, if we had any restrictions here, those would carry over, but we don't. So now we look at f of g of x, which is 2x squared plus 1. We can put any number in here, square it, multiply it by 2, and then add 1. So it doesn't matter what we put in there, so again, it's all real numbers. And for g of f of x, we have 4x squared minus 28x plus 53. Again, we can plug anything in there, so we get all real numbers. Now, for example 2, we are going to let f be 4x to the negative 1 and g of x equal 5x minus 2. So we're going to find f of g of x. So we're going to start by taking g, which is this, and plugging it in here. So 4 times 5x minus 2 to the negative 1, which is the same as, negative 1 means put it in the bottom of a fraction, so our 4 stays up top, and 5x minus 2 goes to the bottom of our fraction. Okay, so now g of f of x. Start with f, plug it into g, so f, or 5 times 4 times x to the negative 1 minus 2. 5 times 4 is 20, x to the negative 1 minus 2, which is 20 over x, because again, to the negative 1 power means make it a fraction, minus 2, just like that. And now f of x. So 4 times, we're plugging all of f in where the x is in f. So 4x to the negative 1 to the negative 1. So because we're multiplying here, we can distribute this out. 4 times 4 to the negative 1 times x to the negative 1 times negative 1, which is a positive 1. So the negative means it goes in the bottom of a fraction. So I get 1/4, and then x stays just like that. 4 times 1/4 cancels, and I just get x. Now for the part, finding the domain of each composition. So, first, we're going to start with the domain of f. So, remember, this is the same as 4 over x. And we cannot ever divide by 0. So, that means that x cannot equal 0. So, there's our domain for that one. Then g, move it back down here, we have 5x minus 2. We can put a fraction, we can put a negative, it doesn't matter what we put in here, we'll always get an answer. So for this one, it's all real numbers. Now, for f of g of x, okay, we have to keep any restrictions here. So we know that x cannot equal 0. And this basically means anything works, but this says that 0 doesn't work. So we have to carry that down. And now we look at our equation. So our equation for f of g of x is this. And again, we have a fraction. So we have that the bottom of our fraction, which is at, cannot equal 0. So now we solve for x. So we add 2. 5x cannot equal 2. Divide by 5. We get that x cannot equal 2/5. So I'm going to add that to my domain down here. So x cannot equal 0 and cannot equal 2/5. Now g of f of x x cannot equal 0. And so now we look at this. Again, we have a fraction. We cannot divide by 0, so x can't equal 0. Well, we already have that. So we can leave it just like that. And then f of x. Again, x cannot equal 0. Now we look at our equation. It's just x. We can put any number there. So our only restriction is x cannot equal 0.